Hello, welcome back to our channel. Today we are going to discuss about crash course belongs to waves chapter. So what is the use of the crash course? So while writing the exams, before that, for revision purpose we are using the waves. Once we are discussing what are the formulas and what are the concepts are there in these waves. So it is definitely useful for NEET, Eamcet and mains also. Don't miss this class. And one more thing I want to share with you. So just you have to follow the day 1, day 2 programs also. Already I have completed units and measurements. Later I will discuss with previous year's problems also. Anyway, today's our topic is the waves from the second year physics. First of all, what is the wave motion? See, if there is no wave motion, we can't imagine the situation also, because we are depending on the mobiles, we are depending on the TV programs, even some like vehicles also, sensors they are using. So everything these are depends on the waves only. What is the wave motion and what is the waves? So you know that when the bullet is fired from the gun, the bullet is moving because of the kinetic energy. Water is lifting to the some height. You can say those are having the potential energy. Like that, this is also a disturbance is propagating from one place to the another place, or the disturbance is propagating into the space without movement of the matter. There what happens? Water is lifting through the certain height and bullet is also moving from one place to the another place. But here what we should observe that whenever the disturbance is propagating, no, matter is not moving from one place to the another place, but we can observe that but the information is moving from one place to the another place. This type of motion is called the wave motion, where we should observe one good example I am giving to you. Suppose one lake is there, we are dropping one stone in that, so you can observe the disturbance. How you can observe the disturbance? Some like up and downs of that water waves we should observe in that. At the same time, you drop one cork also. Cork is not moving from one place to the another place, just it will go up and coming down, go up and coming down. So from this what you are understanding, the disturbance you can go that from that dropped position to the that all directions, but the cork is not moving. Why? This is only called the wave motion. Without propagation of the matter, the energy or the information that is moving from one place to the another place, that is called the wave motion. But there are two types of waves are there. What are those? Just we have classified that there are two types of waves are there. What are those? Some waves, no, compulsory requires the medium to propagate. Can you say one example for that? See, when I am teaching, you can able to listen in the classroom. Why? Sound is propagating from one place to the another place on the earth. Why? Presence of medium is there. Same class I am taking on the moon. Can you listen that sound? Can you get the information? No. Why? There is no atmosphere on the moon. From this what you can say? For the propagation of sound energy, compulsory we requires the medium. That type of waves are called what? Mechanical waves. Then when you know the mechanical waves, you can guess the what are the non-mechanical waves. What are the non-mechanical waves? The waves which are not requires any medium to propagate from one place to the another place. Can you say the good example? Daily we feel that, and without that we can't survive on the earth. That is nothing but light energy. So light is coming from sun to the earth. Between there is no atmosphere, even though light is propagating from the sun to the earth. This type of waves are called what? Non-mechanical waves. So waves are classified into mechanical and non-mechanical waves. And our next topic is what is the progressive wave? What is the progressive wave? In this only meaning is there. See, the wave which is propagating in an infinite medium, it never comes back. That is called the progressive wave. I am taking this class in open space. Then the sound waves are propagating in an infinite medium. It never comes back. That type of waves, what do you say? Progressive waves. Then progressive waves are classified into two types. One is the longitudinal progressive wave. Longitudinal progressive wave. And second one is the transverse progressive wave. Transverse progressive wave. So these are the two types of progressive wave. When we are discussing about the longitudinal and this transverse progressive wave, before that we have to know about the basic characteristics of that wave motion. Already you know in oscillations and this one, basic definitions. What is the amplitude? The maximum displacement of a vibrating particle or oscillating particle, or in this wave motion, the maximum displacement of that particle from the mean position, that is called the amplitude. Always you should remember that amplitude is represented by A and unit is the meters. Then second one is the phase. It is playing an important role. Always it gives the position and direction of the particle at particular instant or at particular time in space, that is called the phase. Then third one is the time period. The time taken for one oscillation is called the time period. Here you can say that when transverse wave and longitudinal waves also, how you should calculate the time period, I will say that. Then frequency. Reciprocal of time period is called the frequency. You can represent either N or F also. 1 by T. Then wavelength. Wavelength, this is the nu term. It is represented by lambda. The distance between two successive particles in same phase, that is called the wavelength. So while discussing the longitudinal wave and transverse progressive wave, these are the basic, and entire wave motion also, these are the characteristics of wave motion. Then come to longitudinal progressive wave. Then another side we are taking the transverse progressive wave. What is a longitudinal progressive wave? Look here. When we are taking one water tube, here one piston is there, just you can move the up and down of this one. Then what happens? Beginning, molecules are very close to each other. This is called what? Compression. Then molecules are relaxing like water molecules. Then you can say rarefaction. Once again molecules are together, pressure and density are more here, compression. Then once again relaxing. This is the rarefaction. Like that alternate, it forms the alternate compressions and rarefaction. Before that I want to say with you what is the basic definition of this longitudinal progressive wave. See, if any wave is propagating in the medium, the direction of propagation of wave is parallel to the vibrating particles. That is called the longitudinal wave, and longitudinal wave, it forms the alternate compressions and rarefactions like this. And if you want to show, you can show like this also. This is the compression and this is the rarefaction. Once again molecules are together, compression, and this is the rarefaction. Just now I said the particles are in same phase, the distance is called what? Wavelength. So the distance between two successive compressions or rarefaction is called the wavelength, that is represented by lambda. Here the direction of vibrating particles are parallel to the direction of the wave. Like that, when you can go through the transverse progressive wave, we can show like this. This is called the crest trough. It forms the alternate positive pulse, negative pulse, crest trough, crest trough. But the direction of propagation of wave is perpendicular to the vibrating particles. Just you can observe that if the wave is propagating, molecules are vibrating like this, perpendicular to this one. But in this case, if it is propagating, molecules are vibrating parallel to this one. So this is the longitudinal wave and this is the transverse wave. And here also the distance between two successive crests or troughs is nothing but wavelength, lambda. And what is the example for longitudinal wave? Sound waves are the examples for the longitudinal wave. And here light waves are the examples for the transverse progressive wave. So these are the two types of the progressive waves. Then we are going to discuss about what is the displacement of progressive wave. How to calculate the displacement of the progressive wave. It is very, very important. That is the displacement of progressive wave. Just now I have given the wave which is moving in an infinite medium, it never comes back. That is called what? Progressive wave. But here how to find out the displacement? We are showing this, that compulsory it is having the simple harmonic motion. We can take it y equals to A sin omega t plus or minus phi. If you are taking sine wave means it will start from 0 like this. Like that you can express in terms of cos wave also. Y equals to A cos omega t plus or minus phi. Plus or minus phi. So already you know this is in oscillations. But how to calculate in this? Look here. Y equals to, we are taking generally instead of phi, suppose y equals to A sin omega t. The wave is starting from the origin. Here the time is t seconds. After traveling a distance of x with speed v. Here time is how much? T dash equals to distance by speed. Then instead of this y equals to A sin omega, total time difference is giving about the time of this wave now. So we can write it t minus x by v. So y equals to A sin, when we are doing the simplification, omega t minus omega by v into x. Then y equals to, I am writing A sin, you know that instead of omega t minus omega by v is nothing but we are taking one constant. Here k is very important. K is the propagation constant. This is the propagation constant. This is the propagation constant. You remember that this value is how much? Look here. Omega we can able to write 2 pi n. Just now you know that instead of frequency, reciprocal of the time period is called the frequency also. Like that k equals to two formulas we are getting, that is omega by v. Omega we can write it 2 pi by t into v. So after that we can write it, this is the 2 pi by lambda also. Instead of these two we can write it the 2 pi by lambda. So this is the propagation of constant, and you should remember that this is the y equals to A sin omega t minus kx. But when we take minus and when we are taking plus, I am saying detailed explanation. Look here. So displacement of progressive wave, don't stick only for one formula. Look here. When we know the omega, we should use. When we know the k, when we know the frequency, when we know the time period, when we know the velocity. So different forms are there to find out the displacement of the progressive wave. Look here. Y equals to A sin omega t minus kx. When this is the sine wave, like this we can show that. That too it is going along the positive x-axis, we can take the minus. Or look here, I am taking y equals to A sin omega t plus kx when it is moving along the negative x-axis like this. Look here how much difference is there. So minus is for along the positive x-axis and plus is for along the negative x-axis. Then y equals to, one example problem we are discussing. They are asking 2 sin 4t minus kx. 8x we are taking. Find amplitude. When we are giving the taking the comparison of these problems are like this only. What is the amplitude? Amplitude equals to 2 meters. Omega equals to how much? 4. Then k is how much? K is how much? 8. And then they are asking how to find out the velocity of this wave here. We know that k equals to omega by v. Just now we know that omega 2 pi by lambda and all these, no? So here omega k equals to two formulas. One is the omega by, here you know the amplitude and omega, and k is the 8. From this how to find out the velocity? You know that k equals to omega by v. From this v equals to omega by k. Omega you know that 4 and k is the 8. So our answer is how much? 0.2 meters per second when they are giving this is in meters. Sometimes they are giving in centimeters also, we can express that is the centimeters per second. So this is the one of the model how to calculate this one. Then same model, suppose the problem is like this. Look here. V equals, they are giving y equals to, and we should write it a sine, it should be right instead of omega 2 pi n into t minus 2 pi by lambda into x. 2 pi by lambda into x. In both the things, which is the common, sine 2 pi by lambda I am taking the common. Here we are getting, here no lambda, no, so that's why we are multiplying and dividing with lambda, n lambda t minus x. Then it should be right y equals to a sine 2 pi by lambda. Instead of n lambda we are taking velocity into time minus x. Okay, suppose the problem is like this. Example, y equals to 8 sine 2 pi by 4 into 3t minus x. Here only x is there and clearly 2 pi by 4 is there. So find the amplitude, wavelength, velocity. So no need of doing any simplifications. When you are taking the comparison of these two, what you are getting, amplitude equals to 8 meters. Then lambda equals to 4 meters. Beside of the t, what is there? Velocity is there in this case. So velocity equals to how much? 3 meters per second. So a equals to 8 meters, lambda equals to 4 meters, and velocity equals to 3 meters per second. This is the use of from the displacement expression we can find out the values of amplitude, velocity, propagation constant and all this. Look here, one more expression we are taking. Y equals to, it should be right a sine, only 2 pi we are taking the common. You can get it nt minus x by lambda also. Suppose they are giving one example. Look here. If y equals to x also we can take it along the x direction. Along the y axis we are taking the displacement is the y. If y equals to 4 sine 2 pi into 8t minus 3 by x by 4. See. Find the amplitude, frequency and wavelength. So no need of doing all these things when you are doing the comparison of these two, because here 2 pi is there, not 2 pi by lambda. From this amplitude is 4 meters. Then beside of t, what is a frequency? 8 hertz. Wavelength lambda equals to 4 meters. Like that we have to do the simplifications when we know the displacement of the progressive wave. Now we are going to discuss about this is the displacement of progressive wave. Just now you know that how many types of progressive waves are there. There are two types of progressive waves. One is the transverse progressive, another one is the longitudinal progressive wave. So now we focus on what is the speed of transverse wave in stretched string. We remember that transverse wave is propagating only in solids, not in fluids and gases. But longitudinal wave we can observe in solids, then fluids and in gases also. But now we are going to discuss about speed of transverse wave in stretched string. Very, very important concept. See, for this we are taking one rigid support. This is the string, one pulley is there. We should attach one mass, that load or mass you can say that. So here from the units and measurements we can write that expression for velocity is v equals to under root t by v. Here t belongs to tension, not your tension and my tension. Tension is nothing but weight of this one, and mu is the linear density. This is the linear density. And what is the formula for linear density? Mass per unit length is nothing but linear density. So how to write the speed formula? Suppose if t equals to 14 newtons and this mu equals to 1 meter per kg per meter. Then how to find out the speed of this one? Under root 40 by 1. So under root 40 meters per second. Like that we can calculate. And one more formula I want to give that. Suppose if T equals to 80 newtons and mu equals to 2 kg per meter. Then how to find out the speed of transverse wave when you know the tension and linear density? Directly you can do that one. 80 by 2. This is how much? Under root 40. So like that, based on, suppose we are taking, this is 20 we are taking. We are taking 20, 0, 0 cancel. We are getting under root 4 is the 2 meters per second. Like that we can calculate the speed of transverse wave in stretched string when you know the tension and linear density. But don't stick only for one formula. Look here how many forms we are writing in terms of mass, in terms of length, everything we can express. Look here, I am writing V equals to under root tension by, it should be right, instead of linear density, mass per unit length means length is coming as a numerator. So V1 by V2 we can write it when you know the tension, mass and length, T1 by T2 into L1 by L2. But here mass is inversely proportional to this one, means we can write it M2 by M1. This is one method. Then in terms of volume also you can express, see, length by, this is the mass equals to volume into density. So it should be right when you are expressing in terms of volume. V1 by V2 equals to under root T1 by T2 into L1 by L2 into volume 2 by volume 1, because it is inversely proportional to speed of that one. So rho 2 by rho 1. This is the density of this one. Especially in the case of two wires and two different loads and two volumes and two different lengths, how to find out the speed of the transverse wave means we can use this formula. Then come to our next application. Look here, V equals to, we are writing, see, tension into length. Volume we should write it area into length also. Now you check here, length cancel. When we are writing in terms of area, we no need of considering the length, tension by A into rho. When we should go through the comparison, V1 by V2, we can express this is T1 by T2 into A2 by A1 into rho 2 by rho 1. Rho is the density, don't confuse. So not only this one, look here. Here we are expressed in terms of tension and density. Here volume, density, tension. Here mass and tension, like that. Now V equals to, we can take it. See, suppose the wire, what is the area of the wire? You can write it pi r square also. So under root tension by pi r square into density. Here we can write it V1 by V2 equals to under root T1 by T2. Pi is a constant and rho 2 by rho 1. Square is a radius square, R2 by R1. Like that, in terms of radius, density and tension also we can calculate the speed of the transverse wave in stretched string. Now V equals to under root, this is the tension is over, area is over, and finally I am writing T equals to A by rho. But from the first year mechanical properties of the solids, in terms of Young's modulus also you can express this one. You know that Young's modulus is stress by strain. Stress is nothing but tension, strain is a delta L by L. So instead of tension we can write it under root T is what? Y into delta L by L into area into density. In terms of temperature also, suppose we are changing the temperature, how to write the expression for delta L? We know that alpha equals to delta L by L into change in temperature. So instead of delta L by L, we are writing alpha into change in temperature. Alpha is the linear coefficient of expression. So V equals to, look here, under root Y by A into rho. But instead of delta L by L, we are writing alpha into change in temperature. See, like this, you see, beginning we have started with speed of this transverse wave in stretched string is what? Under root tension by linear density. That is like basic, but when you know the area, you can calculate volume in terms of mass, in terms of temperature, in terms of Young's modulus. So how many in terms of radius? Many applications are there based on this. Not only this one, few more formulas are there based on this. Suppose we are placing this load into water. We are placing this one into water. Then which parameter is changing? Tension is changing. Why? Tension formula is mass into acceleration due to gravity. Look here. We are taking water like this. We are placing. Tension equals to mass into acceleration due to gravity. Whenever we are placing this is in water, which is changing, G dash equals to G into 1 minus density of liquid by density of the body. Don't confuse. This is the density of liquid or fluid also you can say that, and rho is the density of that body. Now how to write this one? V equals to under root T. Instead of T, what we are taking? M into G dash. G into 1 minus sigma by rho into divided by, as usual we can take the linear density. Like that few more formulas are there. We are taking V1 is the velocity or speed in air of transverse wave. V2 is the velocity in like water. Then how to find out the speed of this one? V equals to V1 square by V1 square minus V2 square. If one more fluid also we are taking, V equals to, we can write it V1 square minus V3 square by V1 square minus V2 square. See, based on the speed of the transverse wave, many formulas we revised. Our next topic is the speed of longitudinal wave. You know that longitudinal wave can able to travel in solids, liquids and gases also. So individually we are discussing these formulas. Speed of the longitudinal wave in solids is under root Y by rho. Y belongs to Young's modulus. This is the Young's modulus and rho is the density. Then in liquids, speed of longitudinal wave, it depends on the bulk modulus. So we are writing B by rho. So B is the bulk modulus. This is the bulk modulus. Then V gases. In gases it is gamma P by rho. Here P belongs to pressure, rho belongs to density. Don't confuse. And gamma is the ratio of specific heats. We should write it Cp by Cp. So this is the speed of longitudinal wave in solids, liquids and gases. And it should be expressed in gases. Look here, V gases equals to under root. You know that PV equals to nRT formula we are using, or MRT also we are taking. See, gamma, instead of this one we are getting gamma RT by V also. Gamma RT by M, sorry. So here this V is directly proportional to absolute temperature. This is inversely proportional to molecular weight of that one. And you know that what is the RMS velocity of the gases? V RMS equals to under root 3 RT by M. 3 RT by M. And at 0 degree centigrade, at 273 degree room temperature also we should calculate. You should remember that V naught equals to Vt into 1 minus T by 546. We are using in the experiments also how to find out the velocity of the sound with the help of the resonating air column apparatus. We are using this formula. So this is the speed of longitudinal wave in solids, liquids and gases. Then we are going to discuss about relation between, actually we have to discuss, this is beginning only, relation between phase difference. Phase difference is represented by delta phi, and path difference path difference is represented by delta x. See, you know that phi 2 minus phi 1 equals to omega 1 omega t2 minus omega t1 like this. So this is the delta phi, and we should write it omega t2 minus t1. I am writing delta t. Then delta phi equals to, we know that this is the 2 pi by t also we are writing into delta t. And one more expression, generally we are using this after simplification. It should be right 2 pi by lambda into delta x also. Why? Here time by frequency we can take it in terms of delta x. This is the path difference and this is the phase difference. It is very important formula. Now we are going to discuss about principle of superposition. Just till now we discussed about one progressive wave is there, displacement, how to calculate, and how to find out the speed of the longitudinal wave, and how to find out the speed of the transverse wave. All these we know what is the displacement of that progressive wave. Everything we know that. If more than one wave is there, what happened? How to find out the displacement? Suppose at the same time 10 members are speaking. So we can't identify whose voice it is. So 10 waves are traveling and all are superposed together. We are getting that new sound and we are getting that new displacement. So principle of superposition we are taking, that is the algebraic sum of the displacement of individual waves. Suppose principle of superposition. Look here, y equals to, we are taking y1 is the first wave displacement, y2 is the second wave displacement, like that yn we are taking. We are taking only two waves. Look here, y equals to y1 plus y2. You know that displacement of the progressive wave I am taking a1 sin omega t. Displacement of second one is the a2 sin omega t plus phi. So what is the phase difference between these two? Phi. Then how to find out the resultant amplitude of this one? We can go through the parallelogram law of addition of vectors. A equals to under root a1 square plus a2 square plus 2a1 a2 cos theta. When we know the cos phi, when we know the amplitude, we can able to find out the intensity also. See, A is directly proportional to I square, I is directly proportional to under root A. So here instead of A, what we are taking, this is the I square. I square equals to under root. When it is coming, it is A square. Instead of A square, we can write it, that is the intensity square. So I equals to I, otherwise I equals to under root, instead of A1 square, sorry, this is intensity is directly proportional to amplitude square. Then A is directly proportional to under root I. So instead of A, we are taking under root I equals to under root, instead of A1 square, I1 square plus I2 square. Same concept you are getting in wave optics also. Instead of A1 under root I1, instead of A2 under root I2 cos phi. From this we can find out A maximum and A minimum also. When you will get the A maximum? When phi equals to 0 degrees, A1 plus A2. When how you will write A minimum? A1 minus A2. In terms of intensities also we can express this one. Instead of A1 under root I1 plus under root I2. And this is under root I1 minus under root I2. Then A maximum by A minimum. What we are writing? A1 plus A2 by A1 minus A2. These formulas are very important. Like that, in terms of intensities, under root I1 plus under root I2 by under root I1 minus under root I2. So like that we can find out the I maximum by I minimum also. So I maximum by I minimum is nothing but maximum amplitude square by, so under root I1 plus under root I2 by under root I1 minus under root I2 whole square. So like this we can calculate the displacement of different waves are combined together. Then this is finding the resultant amplitude, finding the resultant intensity. When we are removing the square, we are getting I1 square plus I2 square plus 2 into under root I1 I2 cos phi. Thank you everyone. Please subscribe my channel, and further topic, second part of the waves, tomorrow we are going to discuss about that. In that we have to discuss about stationary waves, open pipe, closed pipe, beads and Doppler effect. Thank you everyone.